Hello everyone. Today's lesson is all going to be on memory today. So remember, this series is all to do with trying to give you as little as possible to remember so that it's going to maximize your time for revision and you can do it in an as efficient way as possible. This is going to be for the IGCSE spec. So this is going to be looking at memory today. If you are doing one of the other specs, go and have a look at one of the other videos. The spec points we're going to go through today it's going to be to do with embedded systems, RAM and ROM, primary storage, and virtual memory. Spec point, this one, so we're going to just quickly look at the embedded systems. Embedded systems, the general kind of questions that you could get is describe embedded systems and give examples of it. What I'd be saying is it's a computer system within a larger system with one purpose. This is something like a fridge or a microwave. As you can see on the next spec point, it's also talking about how it may give you a particular situation to do with like a car or a security system, just up here, lighting system. So what we need to do is we need to be able to apply the embedded systems to the definition to these particular scenarios. So in a car, you've got a parking system, GPS, and automated windows. So if you ever think about some of the other ones as well, it's just little computer systems that do smaller activities in there. The final one there is describe a general purpose computer, which a general purpose computer is the reverse of an embedded system. It performs multiple tasks on multiple purposes. This would be a desktop computer. Also that you've got iPads, tablets. That is what a general purpose computer is. The next points that we're going to have a quick look at is primary storage and what actually primary storage is, and then also what secondary storage is. So primary storage is a piece of memory that is directly connected to the CPU. RAM and ROM come under this, but also cache and the registers do. The next point being describe and give an example of secondary storage. This is non-volatile, permanent storage for files and applications when they're not in use by the computer. The RAM is what holds it when we are using it, just like this PowerPoint. The next point, understand the differences between RAM and ROM. What I've tried to do is condense this down into a table that you can just have a look at the purpose, whether it's read and write capabilities, and what does it store, and whether it's volatile or non-volatile. Quick definition for volatile and non-volatile. Volatile is when it does not have power and then you turn it back on, it has forgotten everything. ROM is non-volatile, and other things are non-volatile, but non-volatile is just all to do with when you turn the power off, it will remember everything even once it has lost power. So RAM stands for random access memory, and its purpose is to store instructions and data in use by the computer in the moment. ROM stores the BIOS and bootloader program. Read and write privileges. RAM, you've got read and write. ROM is read only. So it's just read-only memory in there. What does it store? So in RAM, you've got instructions, data, and the operating system that is in use currently. And then ROM is the BIOS and the bootloader. We've already talked about whether it's volatile and non-volatile, but if you get that table down, that's a nice easy way to have the differences between them, where if you get potentially a 6 marker, you can just use these different points to help you. Final spec point for today is going to be looking at virtual memory and why we use it. So virtual memory is when we use part of the hard drive as RAM because we've ran out of space on the RAM. Now, what it may follow on to say is why it isn't always so good to use virtual memory. It's okay to use for small periods of time, but the thing with virtual memory is the computer will be very slow, as memory has to be loaded from the HDD into RAM and then into the CPU. So the fetch, decode, execute process is going to go from RAM and it's just going to take it immediately into the CPU. With virtual memory, it has an extra step, and this is what's called paging. So it goes from the secondary storage into the RAM, which is then where it's going to be fetched by the CPU. So there's an extra step which slows everything down.